Determine whether the function f of x equals 2x cubed minus 3x plus 1 satisfy the conditions of the mean value theorem on the interval from -2 to 2, and if so, find the points guaranteed to exist by the theorem. Okay, our two conditions for the mean value theorem: we need to have a continuous function on the closed interval. Here's our closed interval, -2 to 2. Our function is a polynomial, and so it's continuous everywhere, so it is continuous on that closed interval. And we need to have a function that's differentiable on the open interval, in this case from -2 to 2, and a polynomial is differentiable everywhere. So we do meet our conditions of the mean value theorem. So the mean value theorem says if you meet those conditions, there exists a c on the interval from -2 to 2 such that the derivative at c, so the slope of the tangent to the curve at c, equals the slope of the secant line that joins up the two endpoints. So here is just our equation for our slope. So let's go ahead and see if we can figure this out. Let's take and find the derivative of the function. That's going to be 6x squared minus 3. And if we evaluate that at c, we'd have 6c squared minus 3. So 6c squared minus 3 would need to equal, let's go ahead and compute the slope of the secant line that joins up the points -2 and 2. So let's find the function at -2. It's going to be 2 times -2 cubed minus 3 times -2 plus 1. So that is going to be -16 plus 6 plus 1. So it looks like we've got -9 minus, let's go ahead and figure out, I'll put it down here, the function at 2. So that's going to be 2 times 2 cubed minus 3 times 2 plus 1. So that's going to be 16 minus 6 plus 1. So that is going to be 11. So minus 11 over, I'm looking to see what I called A and B. I used f of -2 first, so that one must be our B here. So we're going to have -2 minus 2. I just needed to not turn those around, so I had to stop and check that out. Okay, so this is going to be -20 over -4, which is 5. We can now solve this for c. 6c squared minus 3 equals 5. So 6c squared equals 8. And c squared equals 8/6, which is 4/3. So c is going to be plus or minus square root of 4/3, which is plus or minus 2 over square root 3. And there actually is no reason to have to rationalize in calculus unless for some reason they told you they needed you to. And so there are two values at 2 over square root of 3 and -2 over square root of 3, where the slope of the tangent to the curve is parallel to the slope that joins up the points where x equals -2 and x equals 2. So these values are going to be, I was looking to see if both of them were on this interval, and they both are, because this is approximately plus or minus 1.15. If we looked at the graph here from -2 to 2 of this function, and we joined up those two endpoints of the interval from -2 to 2, and we looked at the slope, we can see that there are two places where the slope of the tangent to the curve is equal to the slope of this secant line.